linear algebra. Okay, so chapter 1. The course is so Miss Anuri. She's not there. Okay, so
Yes, sir.
okay, this is 22306 or 2206.
Yes, sir.
Which one?
2306
Yes.
and 2306, sir.
Yes. 2306. 230.
And 2207.
Yes. Okay. CMT 2306. CMT 2207. Okay. That is the course code. Title is let me
Recording stopped.
wait. Miss Sanri, it's 2306 strokes CMT 2207. Correct, na?
Yes, sir. It is mathematics for technology too, sir.
Yeah, it's I'm writing it mathematics for yeah.
Recording in progress.
Okay, so the title of the course is Mathematics for Technology 2. The course codes are CMT 2306. That is for students who are taking this as a 3-credit course. And for others, it is 2207. The second digit indicates the number of credits. So this can be taken as a 3-credit course also. For some, it's a 3-credit course. For others, it is a 2-credit course. But the first part is common to everyone. Okay. So first topic is on linear algebra. So let's start with, let's say, chapter 1. Chapter 1. Linear algebra. Linear, my handwriting, if I'm going fast, please let me know. Linear algebra. Okay. You have done algebra now. You have done basic algebra, but now this section, this topic is linear algebra. What do we study in linear algebra? You remember, yeah, you did solutions of systems of equations for O level, like x plus y equals 7, 2x plus 3y equals 8. And you are asked to solve the equations, systems of linear algebra is the study of basically systems of linear equations. So to start things off, let me first introduce some terms. The first thing is, what is a linear equation? So that is why this linear word is there in the title, linear algebra. It's a whole big theory. behind those O-level මතකද සමගාමී සමීකරණ කියලා කිව්වේ systems of සමගාමී සමීකරණ simultaneous equations. We did it for O-level, you did only 2 equations in 2 unknowns. I'm saying words that you might not understand straight away, but I gave you an example. What systems of equations are there when I said that example. Now, so linear algebra is the study arising out of linear equations. So we say if you have more than one linear equation, we say that it is a system of linear equations. Let me first define what a linear equation is, linear algebra. So first thing to define is a linear equation. What are linear equations? Now you should pardon me. Linear equations. What is a linear equation? So so that is the first linear equations. What is a linear equation? Example is like 2x plus 3y equals 5. That is an example of a linear equation. Okay, this example. Another, so how many variables are there? 1, 2. X and y are the variables. 2, a coefficient, a constant, a number in front of a variable. We say it's a constant. So 2, just any real number. Plus 3y. Y is a variable. 3 is the coefficient of y. Coefficient of y. So 5 is also a constant. So that is an example of a linear equation. Shall we give another one? Second example, let us make the number of variables more than 2. Say 3 variables, something like minus 3x plus 4y minus 3z equals 8. That is an example of a linear equation. How many variables are there? Variables x, y, and z. There are 3 variables and these are constants. Minus 3, 4, minus 3, 8. Okay, that is a linear equation in 2 variables. First one is a linear equation in 2 variables. 2 variables. Second one is a linear equation in linear equation in 3 variables. This part of the course is much easier than the things that you studied in the first course, meaning the Mathematics for Technology 1. This is Mathematics for Technology 2. No? Okay, right. So, but this section is much easier. Very little background is necessary. So, easy to understand. Linear equation. So, see whether you understand what I have said so far. Linear equation in 3 variables. Okay. So, how do you write down a linear equation in? So, the only 3. So, 4. I need 4 letters to represent variables. How do you write down an equation in n variables? How do you write n variables? Words in the alphabets are not enough. If there are 3 million variables, it will be very difficult to keep track of the letters also, and then all alphabets put together would not give us enough symbols to represent that many variables. So first thing, we have to now come up with a notation. How do we represent n variables? N variables is 2 variables xy, 3 variables xy, z. How about n variables? Variables are quantities to be found. Variables change. So n variables. How do you represent n variables? If you want to represent n variables, then these type of notations are not good enough. N variables, we say first variable, second variable, third variable, and up to n variables. First variable, we shall use the subscript notation. N variables can be denoted by x1. Second variable, x2. It's like xy. If there are only two, we could use xy or x1, x2, the variables. What is the third one? X3. We don't know what n is. If it is 25, we have to write 25 terms. x1, x2, x3, up to x25. N variables. Now n is a positive integer. N variables, x1, x2, x3, we cannot continue without knowing, name the variables without knowing what n is. N can be any positive integer. So nth variable, we shall denote it by xn. That is the notation. N variables are denoted by x1, x2, x3, dot, 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 xn. Or you could use a different letter, y1, y2, y3, up to yn. That is the number of variables. The variable consists of two pieces, no? X and then this number, subscript. So first variable, second variable, x2, x3, and nth variable, xn. Okay, so that is how you denote n variables. So what is an equation, linear equation in n variables? A linear equation, this is Q, linear equation in n variables. N variables look like, in linear equation in n variable looks like what? Now I need how many coefficients to write down a linear equation in two variables? I need two coefficients and two variables. Here in this example, linear equation in three variables, I need three letters and three coefficients, and then equal sign is there, number is there. A linear equation in n variables look like, so I need n variables, I need n coefficients also. COEFFICIENTS. N coefficients, again I need n numbers. In variables, we use this. In coefficients, I need n numbers. Let us call the numbers. First number A1, that is the number that goes with A1, X1, A2, A3, dot, 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 AN. I need n coefficients. So how do you form a linear equation? You multiply the variable by a constant. Linear equation look like A1, X1, like 2x or minus 3x. A1, X1 plus A2, X2 plus dot, dot, dot. What is the last term? Can somebody tell me? You have to multiply the variable last
ANXN
Very good. Yes. ANXN. And I need another number equals to for like 5 or 8 there, let us put B. Okay. So in variables are x1, x2, xn. Coefficients are a1, a2, an. Then this is also a constant where b is a constant. So that is how a linear equation in n variables look. It looks complicated in the notation, but there is nothing we are talking about this when it comes to smaller number of variables. Okay. So let us now give again examples of linear equations. Now you have a definition. This is the definition of a linear equation. Definition. So to check whether something is a linear equation, we have to check whether these are the given equation is of this form. Maybe so we have to have numbers, variables, plus numbers, variables, and then another constant. Let us say we said name them here, no, variables x1, x2, xn. Coefficients a1, a2, an. Then there is this b, no? So this b is just a constant. B is a constant. Not to be confused with a variable. Constant. B is a constant, meaning just a real number. Now examples of linear equations. Okay, there is nothing to go home and study. Okay, study later. Just keep the form here. Let us learn it. Then and there examples. So I will give one example. I have given 2 examples earlier. Again, now we have a precise way to understand what a linear equation is. If it is of this form, we say it's a linear equation. Something like x plus 3y equals 5. Now you say you wrote x1, x2, xn. Now you are using x and y. The same equation can be thought of as this is the same as, so for example 1, or we can say x1 plus 3x2 equals 5. Now these two represent the same equation in different notations. O-level notation, here this might look like 1 times x. So x plus y equals 5. The variables there are, I have used x, y, letters. Only 2, no? Or I could have used using this notation, same equation, x1 plus 3x2. Variables are letters representing variables are x1, x2. 1, 3 are the coefficients, b is the constant. So it is in this form. Therefore, it is a linear equation. Another linear equation, let us use x1, x2. I just did this because this is what you are familiar with. You haven't done O-level linear equations using this notation. But now you see that that notation that you used for simultaneous equations in O-level, you can do it only for few variables. Letters, number of letters in alphabets are not sufficient to large number of variables. That is why we switch to x1, x2, xn notation. Okay, that is a linear equation. These are the same. These two equations are the same. I want to say that same equation. They are the same. Only thing is that we have used different notation to denote variables. This is a more efficient way to do it when it comes to large number of variables. As an example of another linear equation, let us use this notation. 5x1 minus 3x2 plus half x3 equals 3 over 2. Is that a linear equation? three variables, x1, x2, x3, coefficients 5. Here we said plus, but I have put minus. So what is, if you are matching this to this, what is A1? A1 is 5, x1 is there. A2 is, what is A2?
Minus.
Minus 3. Because minus 3 is the same as plus times minus 3. So although this says plus, we can have minus. Only thing is that A2 is now minus 3. What is A3? Half. B is 3/2. Another example. So I put different types of coefficients there. This is also a linear equation. Third one, let us say 3x1 minus pi x2 plus x3 minus square root 2 x4 equals 3/7. Is that an example of a linear equation? Crazy looking numbers are there, no? This is okay. 3x1, a1 is 3, a2 is minus pi. Pi is a real number. And plus ex3. Remember that E 2.718 roughly. Here 3.14 or 22/7 roughly. We know these two are irrational numbers. This is also an irrational number. Minus square root 2, something like 1.4 approximately. X4 equals 3/7. Our B is 3/7. Why did I write such a crazy looking equation? Just to let you understand this A1, A2, AN, when they say they are constants are just real numbers. Real numbers. Real numbers. Constants are real numbers. So A1, A2, AN could be any real number. It doesn't matter whether it is an integer, it's a rational number or an irrational number. We mainly work with integer coefficients, but when you understand something, you have to understand it in its full generality. How are things so far? So if I give you a linear equation, if I write a linear equation, you should be able to recognize it as a linear equation. It's about the way we learn mathematics. There is a definition of something. So, and if an equation is presented to you and asked whether it is linear or not, all you have to do is to check whether it is in this form or not. Maybe linear. Linear anyway. There is something that I have just not mentioned yet here. This is to understand linear equation. Anything other than here for x1, x2, xn, anything other than the variable itself. Like if I put square root sign, square root x1 is not allowed. Sin x1, no. It has to be most simple, like basically like this or this. If it is two variables, it must look like an equation like that, three variables like that. So when you try to understand something, it's not only that we should look at examples, but we should look at non-examples also. Then the concept will sink into your mind more easily. Let me, space is not here enough. Yeah, maybe like that. Fourth example of a linear equation in n variables. Something like, say, fourth one, I write something like x1 plus x2 plus x3 plus ... plus xn. is equal to, say, 4. That is also an example of a linear equation. And how many variables are there? Since we cannot write all the terms without knowing what n is, we can write. We can still match this. We can still match this with that. It's of that form. No? What is A1? Yes.
1.
1. A2 1.
1.
A3 1. AN 1. Okay, pluses are there. Plus or minus, okay. If it is minus, we consider the coefficient to be minus 1. Equals to 4. B is equal to 4. These are all examples of linear equations. Now, next example. So, the all of the above are linear equations. Linear equations. So something you knew for 2 variables, we have now extended that to n variables. All of those 4 are examples of linear equations. Now we go to a different type to understand linear equations better. Let me write, say, first example, x squared plus 3y equals 7. Is that a linear equation? Is this allowed? This is okay. Constant times the variable. Here variable squared. This is bad for linear equations. So this one is not a linear equation. It's not a linear equation. It's an equation in 2 variables, but it's not a linear equation. So understand the word linear. I will come to that again geometrically also. Second one, x plus y plus plus xy. 2xy, say 2xy equals minus 3. Is that a linear equation? What do you think? This term, product of the variables, that's not allowed. So these linear are very, very elementary. No? Just a constant times the variable plus constant times the variable plus so on up to n equals a constant. X squared terms cannot be there, xy. This is bad for linear. This is bad for linear. So this is not a linear equation. Third one, sin x plus 3y equals 8. I'm all using 2 variables. Sin x plus 3y equals 8. Is that a linear equation? What do you think, students? Sin x plus 3y equals 8. You cannot have anything else other than constant times the variable. Sine products, squares, nothing is allowed. This is bad. That is also not a linear equation. Fourth one, square root x1 plus 3x2 minus 5x3 equals 25. Sorry. Is that a linear equation? First, recognize the variables. Variables are x1, x2, x3. So for a linear equation, you can have variable multiplied by a constant, variable multiplied by a constant. But here it is not variable multiplied by the constant. By a constant, it is square root of a variable. That is not allowed for a linear equation. So this part is bad, this is bad. So it's not a linear equation. So you see how elementary linear equations are. None of these types can be considered as linear equations. Now, do you understand it so far? Students, tell me, am I doing it fast or maybe slow? No. Yes, is it okay? We can use the chat box also if you want to slow me down or get any questions answered. If you don't understand something, just unmute and speak. It's completely okay. I don't mind. I just want you to follow the lecture without any difficulty. First lecture, no, it must be to get you attracted to that subject area that we do. If you don't understand the first few things that we say, then everything falls apart. No? That is why. Now we know what a linear equation is. Now, I said linear algebra is the study of concepts arising out of systems of linear equations. System. When we say system, system is more than one here. A system of linear equations consists of more than one linear equation. What is a system of linear equations? I'll write an example. So I'm using more examples to explain the concepts and terms and definitions. So here to explain the definition. Example, consider this 2x plus 3y equals 7 and x plus x minus 2y equals 1. What have I done? I have written two linear equations, like O level, two linear equations. So we say it's a system, more than one system of linear equations, even one. So I'll define the system of linear equations in general. So this is the first example of a system of linear equations. This is a linear equation, it's a linear equation. More. So we say it's a system of linear equations. In the first statement, we can say more than one linear equation, but even one equation can be considered as a system of linear equations. You will see that after I give the proper definition, but this is a system of linear. Can somebody give me a system of linear equations in 3 variables? You think about 3 variables. I'll write this system. I could have written it as 2x1 plus 3x2 equals 7. x1 minus 2x2 equals 1. These are the same system of linear equations. Variables here are x and y. I have denoted x1, x2 notation here. Okay, so same. Third one, same system of linear equations. Only the name of the variable is different. Okay, so system. So this is the word I'm trying to get at now. I earlier explained what linear equation is. So now system is a few consisting of linear equations taken together. Third example, say 2x1 minus 3x2 plus half x3 equals 9. 3x1 plus 5x3 equals 7. Where is x2 term? X2 term is missing, meaning we can consider it as plus 0 times x2. Now, this is also a system of linear equations. You might say there are 3 variables, so we have to have 3 equations. No, no such thing. This is also a system of linear equations. 2 equations in how many unknowns? 3 unknowns. This is also a system of linear equations. Linear equations. How many? So variables are also called unknowns. Variables, little by little, variables are also called unknowns. If I say it in singular, you will run. Agnyat, unknown. Yes. Variables, Tamil also must sound similar. Variables are also called unknowns. Variables, unknowns. So number of, how many equations are there? Here, 1, second equation. So this is a system of linear equations in system of linear equations. How many equations are there? It consists of 2 equations, 2 equations in how many unknowns? How many unknowns are there? Variables. x1, x2, x3. Here also you can say x2 is there. This uses 3. No? So if one uses 3, 2 equations in 3 unknowns. 3 unknowns. So there is no requirement that there should be equations matching the number of variables. There is a special name for those, but this is a system of linear equation. A system consisting of equations like the ones given here, linear equations. Okay, so that is a. So we also can say 2 equations in 3 variables, 3 unknowns or 3 variables. That is also the same. Huh? So we have to get used to different notations. Okay. Now we haven't done anything. No, just setting the stage for the study of systems of linear equations. Just understand the terms that are used. Only it's like an English lesson again. Okay. So far, okay. Please use the chat if you want. If you are afraid to unmute and ask me anything, use the chat. Okay. Now, so let us now get to something a little more complicated, just slightly, but it's complicated in its notation if you haven't seen it before. But there is nothing to be scared of because we have already given 2 examples of systems, although 3, I said 2 because these 2 are the same, using different letters for unknowns. 2 examples of systems of linear equations. So let us another example of a system of linear equations. Half x1 minus 2x2 plus 5x3 equals 7. Minus 3x1 plus 2x2 plus 7x3 equals minus 8. 5x1 plus 3x2 equals 9. 7x1 plus 5x2 plus now you might say, oh, no, it's enough, no, x1, x2, x3. You have given three variables, three equations, no, when it comes to this place. No, you can, well, just to make a point, 7 plus let's put some 8x3 is equal to and 25. Look at this. Is it a system of linear equations? So you have to check whether every equation given is linear. That is okay, no? Every equation given there is linear. Constant times a variable. Constant times a variable. Plus, minus. Same. So, is it a system of linear equations? We don't put like this, but this taken all four equations taken together is a system of what kind? SYSTEM, system of linear equations. System of linear equations. Linear equations in how many variables? System of linear equations. It consists of it consists of I will speak students. Okay, it consists of how many equations? Yes, it will clear. It consists of how many equations? This is an equation. The equation. Four, yes, consists of 4 equations in how many variables?
3 variables.
3 variables.
Yeah, 4 equations in 3 variables. 3 variables or 3 unknowns. So, what is the point there? Yeah, again, you can have any number of equations in any number of variables. That O-level training might restrict you to think that if there are 2 variables, there should be 2 equations. No such thing. Okay. Right. So now we shall write down the general form of a linear system of linear equations. A general system of linear equations. Sometimes we say linear system of equations. A general system of linear equations. Linear equations general system of linear equations in or with n unknowns, n variables. N variables. So let us say the variables x1. Let us take the variables to be x1, x2, xn, xn. How does it look? General system of linear equations in n variables. And shall we say here? Let me introduce that also. In n variables, n variables and m equations. And m equations. Now that I decided to change what I wrote here because I have already told you here. This is an example of a consists of 4 equations in 3 variables. So we can have different numbers for these 2 places. It consists of m equations in n variables. I wrote it slightly differently here. I first wrote down the names of the variables, n variables and m equations. So it's like, it is like in the language given here, consisting of, so consisting of consist of 4 equations. Now what is the number of equations? I said m, consisting of m equations. M equations in n variables, n unknowns or variables. M equations in n variables. M equations in n variables. How does it look? A general system. That is what I'm going to write down. Now, I need, how many coefficients do I need? To write a single equation, I need how many? To write a single equation in n variables, single linear equation in n variables, I need n coefficients. No? Something x1 plus something x2 plus something x3 equals something. That word something was used to denote constants, describe constants. So now we are in, and how many equations? How many equations? Mn equations. Tell me the number of coefficients here. How many coefficients are there? First one, 3, 3, 3. Here also 3, yeah? Because 0, x3, no? 3. Okay. Each equation consists of 3 coefficients. And how many equations are there? 4. So altogether, how many coefficients? Pacharaktina the coefficients. Yes?
12 coefficients.
12, yes. How do you get 12? M times n, number of variables times number of equations. So here I need to, so how many constants? Need m times n or n times m, doesn't matter, they are the same. Yeah. Earlier system 12 variables, 4 and 3. Need mn constants, coefficients. Mn coefficients are needed. This mn coefficients can be divided into first row, first equation, second equation, third equation. So it's we need first equation, go here. Tell me the coefficient. Tell me the coefficient of third equation, second coefficient. What is the third equation, second coefficient, meaning second coefficient of the third equation. So you go here and go there. Okay, third equation and second coefficient. Second. So here, what is this coefficient? Is the 7 is the coefficient of which coefficient? Third coefficient of the second equation. Second equation, third coefficient. So we must now invent a notation to describe these mn numbers, these 12 numbers. Like now I need mn numbers. So how many numbers are there for this one? This is the first one. So let us divide the number of equations. M equations, no? M equations. So this is the first equation, say this is the second equation, dot, dot, dot. This is the nth equation. To describe the first equation, I need how many numbers? I need coefficients. I need so first one should be, yes, it will let us see. So to describe the second one, I need again nth one also. We have to align them and write. So mn. So first equation, I need a number here, of course, x1 plus, maybe it gets complicated. Take that. We have something x1 plus something x2 plus plus something, meaning constant, times xn. How many are there? How many variables are there? Consisting of m equations. So this should be, I said m equations, no, constants දාන්න ඕනේ. M equations. How many variables? How many variables? One, two, n variables. Now, may setup, if you understand this setup, then this notation would be meaningful. So if I want to write third equation, fourth coefficient. Third equation, fourth coefficient. What is a notation? Remember earlier when there are a lot of variables, we had to use the subscript notation. Here also we shall use the subscript notation to denote the coefficient. Third equation, fourth coefficient. Fourth coefficient, earlier we would have written A4, no? Fourth coefficient. But it is now third equation, fourth coefficient. Third equation, fourth coefficient. I need two letters now to denote which equation we are in and which coefficient of that equation. So we shall first write the equation. We shall say A34. What is A34? Earlier we wrote A30, A4, no? Third coefficient, fourth coefficient. Now, A34 means coefficient in the third equation of the fourth variable. Variables. Okay, so now ith equation, jth variable, jth coefficient, ith equation, jth coefficient. What is a good notation? What is the good notation for ith variable, jth coefficient? Ith variable. I is the equation number. Ith equation, like third equation. Aij. That is the notation that we are going to use. So now I have to write how many equations? I have to write m equations, sorry. I have to write m equations in n variables. Now, what else do we need? Now that we know how to denote coefficient. So can you tell me, I need names for variables. We said x1, x2, xn. So write down the first equation. how do I write down the first equation using this notation? What is here? This coefficient is A. Yes, first equation, first coefficient. That is, this will look like A11. What is this one? A,
One,
A12.
two.
What is this one? A, still first equation, no, A1,
N.
N. A1N. What is this coefficient? A. What is the MN? AMN. Do you understand? It's not M times N. It's not A times I times J. It is I for the equation number, J for the J for the coefficient number. So nth ith equation, jth coefficient. Now build up on that. Maybe this is this speed okay? Is it, if it is slow, tell me, huh? Because it's that is complicated, not the content. You will see a few procedures are there, and it will be really easy, because we have made your mathematical maturity to a certain level, which would allow you to understand and do things very easily here. Now write down the system of equations. See, so first, write down the first equation using Aij and x1, x2, x. So coefficients, CIENT, coefficients. What is the notation that we are going to use? Aij. Unknowns or variables. Variables. We are going to use x1, x2 variables, x1, x2, ... xn. In fact, variables for every equation, variables are the same. N variables, M equations. So let me write down the first equation. Can you fill these and write down the first equation? First linear equation in this system I have described is A11 x1 plus A12 x2 plus ... plus A1n, nth first equation, nth coefficient, xn equal to, we'll come to that. So I have put a number there. Go to the next one. What is the second equation of this system that I'm trying to describe? Yes, what should go there?
A21.
A21. What is the name of the variable? X1.
X1.
Yes. A22
x2
plus ... plus align plus sign. So idiot. What is this coefficient? A2n. We don't put a comma and this is not multiplication. When we write, we are understand. Aij means coefficient of ith equation, jth coefficient. Those are the two numbers. If you write two symbols adjacently in algebra, you multiply them. This is also algebra, but this is an algebraic notation. Ith row, jth coefficient. This is equals to, tell me the ith equation. First equation, second equation. I now need the ith equation. We shall write the nth one, ith equation. So what is this coefficient? A ith equation. AI1, very good. AI1 x1 plus A2 I2 x2 plus A, last one, AIN. AIN equals nth one. So usually we don't write the ith one, but ith one, it's there. Then dot here also 3 dots. No? Mth, last one is the mth one. Nth one, maybe I should write here first one, first equation, second equation, then finally mth equation. AIN, something is missing here and here. Coefficient is right, then if it is a linear equation, xn is missing. Sorry about that. Xn here also, xn is missing. xn. Last one, let us mth equation, first coefficient. What is that? Mth equation, first coefficient, variable x1. Second, mth equation, second coefficient, A, there is the pattern, x2, dot. Here, we already answered the coefficient AMN when I asked xn equals. Now, how many symbols are needed? I need to put a constant here, constant. How many constants are needed? 1, 2, 3, M. M. And now I need to describe whatever symbol I use here should be indicating the right-hand side of the first equation, right-hand side of the second equation, right-hand side of the third equation, mth equation. So I only need m numbers representing only which equation it is in. So only one index is subscript is enough. We write earlier, we wrote when we had one equation B, now B in the first equation, B1, B2, B3. Oh, B. BI. It should be BI. BI. What is the last one? B. BM. This is how a system of linear equations look. These are the gadgets that we are going to study. So, this is a general system of linear equations. Complicated looking, no, that's all. Otherwise, these are the simplest of equations, linear equations in n variables. And n variables, how many equations? M equations. Next, we have to explain what a solution of a linear equation is. Okay. When you solve, when we solve an equation, what is required is to find the values of the variables satisfying the equation. Now, if I say 2x minus 3 equal to 0, what is the solution? Sorry. I must get into the habit of putting the numbers from pages. Otherwise, later it will be difficult. That one, yes. 3, 4th page. I will upload the So now look at this. What is the next thing I'm going to explain? What is a solution? There is nothing to explain in a sense. Solution of an equation. What is the solution of this equation? 2x minus 3 equal to 0. Solution. What is the solution? X is equal to
3 over 2.
3 over 2. Why is it a solution of this? So you need to know what a solution is. Definition of a solution. When you substitute this value, equation is put a solution. Why? Why? Everything should be answered and understood logically. Why is it a solution? Why is it a solution? Why? Substitute. Substitute x equals 3 over 2 in the equation. In the equation, what do you see? If you put 3 over 2, so 2 times x is 3 over 2 minus 3. Left hand side of the equation is this. Left hand side, I substitute 3 over 2, I get this. Now this cancels. 3 minus 3 is equal to 0. What is the right hand side? Right hand side of that equation is also 0. These two are equal. Therefore, equation is satisfied. Therefore, the equation is satisfied. Yeah, no, you all know this, but what am I trying to explain here? When we say a solution, what do we really mean? Now, let me ask a difficult question. Now look at now look at 2x plus 3y equals 5. 5 done 8. Look at this equation. How many variables are there? 2 variables, x1, x2, xy. I have written xy. So what is the solution? Can somebody tell me a solution of this equation? From your O-level training, you might say, "Ayyo, sir, there only one equation. How can we find 2 variables?" You have been trained to think that, not trained to think, yeah, you have been made to think that you need 2 equations in 2 unknowns. If there are 2 variables, you need 2 equations to find x and y. Not so. Not so. Can somebody tell me a value of x and value of y? X equals, give me a value, and y equals a value. When I put x and y into this equation, it is satisfied. So that should be a solution. Can somebody guess and tell me a value, a number for here and number for there? Number for this place and number for this place. Value for x and value for y. When I put it and simplify, you get 8. X equals, yes?
X equals 1,
X equals 1, comma, y equals 2. Substitute. So it must be a solution. x equals 1, comma, y equals 2 is a solution. Why? I explained you what a solution means. When substituted, it satisfies the equation. When we substitute, let's see. When we substitute, x equals 1 and y equals 2 into the equation, or put into the equation, understand? Equation, into the equation, it is satisfied. It is satisfied. Therefore, it is a solution. Is a solution clear? Give me another solution. Can you think of another solution? You pick, give me a value for x. There are two. It's like this. Yes. Let us take x to be 2. If you take x to be 2, then what should y be? If it is 2, this is 4. Take it to the other side. 8 minus 4. 8 minus 4 is 4. So y equals, x equals 2, y equals 4 over 3. So I try to substitute. X equals is a solution, is also a solution. Is also a solution. Try left-hand side. Left-hand side. What will happen? 2x. Left-hand side is 2x plus 3y. No? Substitute these values. 2 times 2 plus 3 times 4 over 3. 3 and 3 cancels. 4 plus 4. Which is equal to 8. That is equal to right-hand side also 8. Given to be 8 now in the equation. So, right-hand side is also 8. Therefore, this is also a solution. Can somebody give me another solution of this equation? Another solution.
x4 and y0.
x4 and y0, excellent. X, if you put x equals 4, this is 8, no? 8 minus 8 is 0. So, very good. Yeah, very happy. Let me write the equation again. 2x plus 3y equals 8 is the equation. Okay, so you are saying x equals 4, y equals 0. Is also a solution. Is again also a solution. How many solutions are there, you think, for this equation? This is because when you substitute, see, she took it there to make this 8. So 8 cancels, 3y equals 0, y equals 0. Now if you substitute, you will see that it is satisfied. It's a solution of this equation. How many solutions are there for this equation? When there are a large number that we cannot describe, we cannot list and finish. Say, how many? Infinitely many solutions. In fact, in fact, x equals what? Let us say x equals t. What is t? The first time I took x to be 1, second time x to be 2, third solution, the student took x to be 4. So in other words, what we are saying is you can put anything for x. There is a y. In fact, x equals t, comma, if x is equal to t, what is y? 8 minus x is t, a number, any number. Then y should be 1/3 8 minus 2t. Do you understand how I get 2t? Take it to the other side. 8 minus 2t divided by 3. 1/3 8 minus for any t. What is t? For any real number. Gives us Canada. In fact, x equals t, y equals this, where what is t? Where t belongs to r, any real number. I'm sorry. Where t belongs to r, any real number. In fact, so this value of x and value of y for any t belongs to r, where t belongs to r, give us all solutions. Of 2x plus 3y is equal to 8. How many solutions are there? How many solutions? How many solutions? How many solutions are there for this equation? How many? So you can take any value for t. Very complicated value. Do you understand it? Minus. Yes, a student has given another answer, x equals -2. Yeah, make it. If you take x equals -2, what is y? If x equals -2, -4, then it becomes 12. 12 divided by, so another student has given in the chat, x equals -2, y equals, if x is -2, 12, y equals 4. X equals -2 minus 4, taken to the other side, 8 plus -4, minus -4, plus 4. So 12, 3y equals 12, y equals 4. I did the same thing here. Without putting a number, I said, take x to be any real number. Then if you take y to be this, substitute and see, 2t. When you multiply by 3, 3y is 8 minus 2t. 2t, 8 minus 2t. Minus 2t cancels 8. So every solution, there are no others now. Every solution of this equation is of this form. T can be any number. So can you answer this question? How many solutions? 5, 7, 2, how many? For every real number. Every real number you get a solution. So there are how many real numbers are there? There are infinitely many. Infinitely many. Finite is you can count and finish. Like 1, 3, 7. 1, 3, 7. If you take the set consisting of 1, 3, 7, you can count first one, second one, third one, and finishes. Count and finish. It's a finite set. Real numbers cannot even think of counting. No? That many are there. How many? Not finite, meaning infinitely many. Infinitely many solutions. How many solutions? Infinitely many solutions. One equation. See, you have seen this so many times, no? But people don't actually give the proper interpretations. You have to say things in a precise manner without putting misconceptions into students' minds, okay, or anyone's mind for that matter. So one equation in two unknowns. There are infinitely many solutions. So now that brings us to what we mean by a solution again. So what time is it? What do we mean by a solution? So let us take our linear system of equations. What do we mean by a solution of this linear system? Let us again, it's okay. It takes time, but consider the linear system, general linear system. Consider the linear system. Difficult not to write down a11 x1 plus a12 x2. Row number first, position second. a1n xn equals b1. Second equation, a21 x1 plus a22 x2 plus, not plus, plus a2n xn equals, what is the number? B. Then without writing the ith one, we shall straight away write the mth one. A m1 x1 plus a m2 x2 plus a plus sign plus what is the number? A
mn xn.
mn xn equals b
bm.
Right. Consider this linear system of equations. We just write equations one below the other and continue. Consider this linear system of equations. By a solution, what do we mean by a solution? By a solution, we mean a collection of numbers. It must satisfy a solution. If something is a solution, okay, I have to give a value for variables. So x1, x2, xn. When I substitute the values, this equation must be satisfied. This also, it's not one equation. No. Consider the linear system. By a solution, and that means what I sorry. A solution is a collection of numbers. Collection of, shall we say, real also. If we are only considering real, if the coefficient are complex numbers, then also it's a system of linear equations. Coefficients are complex. Here we are studying only real numbers. A solution is a collection of real numbers. X1 equals T1, X2 equals T2, comma, dot, dot, dot. Xn equals Tn, collection of numbers. You saw the previous example to xy. X1 is T1, X2 T2, Xn Tn, such that numbers satisfying each of the equations of the system, satisfying each and every equation. Each equation satisfying each and every equation of the system. System is system of linear equations. Each and every equation of the system. So when we substitute these values to first equation, x1 equals t1, x2 equals t2, xn equals tn, it satisfies that. So a11 t1, a12 t2, dot, 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 a1 and tn should be b1. Same thing for second one, it will give you b2, and all of the equations must be satisfied. Now, to understand something really, really interesting about systems of equations, we shall now concentrate on linear systems with two equations in two unknowns. And now let me ask you this example, tricky question. Solve x 2x plus 3y minus z equals 5. Oh, thank you. Solve this equation. 2x1 plus 3x2 minus x3 equals 5. How do you solve? What is the solution? How many equations? One equation. Given one equation. One equation. How many unknowns? 3 unknowns. 3 unknowns. One equation, 3 unknowns. How do you solve? One equation, from one good equation, you can find only one constraint. So 2 of the variables must be free. It's like this situation. One equation in 2 unknowns. So the equation puts only one condition on 2 things. So one gets free, gets to fly free. That is why we say x1, let x be t, then y equals this. For any t is a solution, infinity means solution. This is a more more freedom. This is a situation where there is more freedom. Only one condition, one constraint into 3 variables. So you can set 2 variables free. Can you tell me one answer? X equals, what is, if I put 1 here, yeah, 1, 1, 0. X equals 1. I just made the coefficients in such a way that we can easy to, don't worry, we'll tell you how to solve it. X equals 1, Y equals 1, Z equals what? To get the
0.
equation, yeah, 0. 0 is a solution. There are infinitely many. Is a solution. How do you find all solutions? All solutions. How do you write down all solutions? X is equal to, let X be equal to T and Y be equal to, yes, another letter, S. Then go to this equation, then do rough work. What should Z be? Put T, so what do we get? 2x meaning 2t plus 3s minus z is equal to 5. So z must be what? Take z to this side and put 5 to this side. So z equals, z should be equal to, taking this to say 2t plus 3s 2t plus 3 minus 5. S would be 5 don't forget. Yes. So Z equals 2t plus 3s minus 5. Where t, comma, s belongs to R. Let t belongs to y, then you will understand how to do it. No? Then Z equals that, where S and T belongs to R. 3 numbers. So for this solution, I have taken T equals 1, S equals 1, but I can take T equals 25, S equals 95. Then 2, whatever value we took for T, plus 3 times whatever value we took for S, minus 5 is going to satisfy this equation. So solutions are set of numbers. So all solutions are given by these. Understand it. Again, infinitely many solutions. Infinitely many solutions. Now let me, for 15 minutes, let me consider the situation, full picture for two equations in 2 unknowns. Consider linear systems. O-level ones, linear systems with 2 unknowns. With 2 equations. 2 equations in 2 unknowns. In 2 unknowns or variables. Unknowns. Can variables. two equations in two unknowns, 2 by 2. So we can use x1, x2 notation, no familiar xy notation. Right. Nah, පොඩ්ඩක් තියෙන අපි පේන බ්‍රේක් එකක් ගන්න නේද? Linear systems with two equations in two unknowns. Linear systems consisting of two equations in two unknowns. Let us write down two equations in two unknowns. A1, A11, A12 only. So let us use just A x plus b y is equal to first equation. We can come familiar with that. It's A1x B1y equals C1. Second equation A2x plus B2y. Let us enough no the common name him gum. This is similar to this A11x1 plus A12x2 equals B1. A21x1 plus A22x2 equals B2. Make it. All that are required are how many numbers? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Notation it doesn't matter which notation you use. Okay, maybe XY will lazy. We can understand things geometrically better, easily. So solutions. I'm going to look at solutions and these linear equations as geometric objects, points and lines. Okay, example 1. Example 1. Consider this system. Let us take x plus y equals 3. Two x minus Oh, minus y equals 6. Consider this system of linear equations. Geometrically, I want to, how many solutions are there? You can do the O-level method. When they add them, you get 3x equals 9. Right? If you add them, you get, this is the given system. If you add them, you get 3x minus y plus y cancels. No? When you add x plus 2x, 3x, 3 equals 9, you get x is equal to 3. If you put x equals 3, what is y?
Y equals 0.
Y equals 0. Then y equals 0. So what is the solution? Solution x equals 3, y equals 0. Solution. Let us look at this geometrically. Go to the xy plane and draw the two lines. These are two straight lines. No? Two straight lines, x, y. Draw the first line, x plus y equals 3. When x is equal to 0, y is 3. Here. When y is 0, x is, when x is 3, or when y is 0, x is 3. This is the first line. It's a straight line. Straight line, no? Ax plus, what are straight lines? Ax plus by plus c equals 0. Or ax plus by is equal to c. That is a straight line. So if you know 2 points, you can draw the straight line. This is x plus y equals 3. Now draw the other line, 2x minus y equals 6. When x is equal to 0, y is minus 6. Y is minus 6. So this is 3 here, 3 here. Y is minus 6 somewhere here. Y is minus 6 when x is 0. When y is 0, x is 3. That is this point. What is this line? What is that line? 2x minus y equals 6. How did I draw the two lines? I just put x equals 0, and found y. That is the place where it crosses the x-axis, y-axis. Then I put y equals 0 and found x. For both equations, we see that it goes through 0, so what is the point of intersection? Point of intersection, coordinates. Coordinates of the point of intersection. Point common to them, point of intersection. What is it?
3, 0.
Yes, intersection. 3, 0. X equals 0, x equals 3, x equals 3, y, 0, y equals 0 is the only common point. Look at the solutions. Remember? What did we get? X equals 3, y equals 0. So solving two simultaneous equations in two variables is the same as finding the point common to it. Points common to both equations. Points, coordinates satisfying both x equals 0. How many solutions are there? How many solutions? How many solutions? How many solutions? How many solutions are there? Geometrically also we see that only one point of intersection. Only one point common to them. These are the only coordinates. These are the coordinates of the point of intersection. Written in terms of x1, y, it looks like this. Now tell me how many solutions are there? Kiyak the solutions?
One.
One. Only one. One. One solution කියන එකට ලස්සන ඉංග්‍රීසි මොකද්ද? Tamil speaking students, what is the nice way to say just one solution? We use a word in English. A unique solution. Unique. Unique means one and only one. A unique solution. I have 3 minutes left for 2 more examples. I'll do that quickly. A unique solution. So for this system of linear equations, there is one and only one solution. Solution consists of 2 pieces. That's okay. But one point in common. A unique solution. A unique solution in this example. A unique solution. What are the possibilities? When you have 2 equations in 2 unknowns, do you always get infinitely many solutions? Sorry, you always get a unique solution. Okay, that is the first example. Since we can do it very quickly. In second example, example 2, consider this system. Consider this system: x plus y equals 3 and 2x plus 2y equals 6. Now don't tell me that's wrong, that's wrong. No, these are the numbers. What will happen? If you divide, how many equations are there? Tell me. How many equations?
2 equations.
2 equations. How many unknowns? 2 unknowns. X and y, no? But one might say, if you divide this by 2, you get that, no? It's the same equation in disguise. Whatever it is, we have to go by our definitions. According to our definition, this is a system of 2 equations in 2 variables, unknowns. 2 equations in 2 unknowns. They are the same, doesn't matter. But we consider this as, what is A11? 1. A12, 1. B1, 3. A21, 2. A22, 2. B2 is 6. So there are 2 equations in 2 unknowns. Now, these 2 equations are not linearly independent, meaning one can be obtained from the other. That is a different matter. Now let us draw these 2 equations. What time is it now? You have a lecture at 10. Students? You don't have, I know. Yes. So let me just take 2 minutes more. X plus y equals 3. When x is equal to 0, y is 3. 3. When y is 0, x is 3. When y is 0, x is 3. So this is that equation. Straight line. Then this is what? This is x plus y is equal to 3. Now draw the second equation. X plus 2y equals 6. When x is 0, 2y equals 6, y is 3. That is this place. When y is 0, it's the same equation, no, in a sense. So what is the graph of the second equation? That is also it. I have a red pen somewhere. Yes. Second equation, so it's also a straight line, no, linear equations. Remember, we call them linear equations. Now only you know that linear equations are not just there for two variables. We can have it for n variables also. So both equations have the same. If it is a point on the first one, it's a point on the second. Point on the first one, point on the second. Points common to both. How many are there? How many points of intersection? Can you answer? How many points of intersection? Infinitely many. So there are infinitely many. There are infinitely many solutions. There are. Okay, that is the second example. Third one is third example is just this. I'll make two parallel lines. These two are considered parallel also, one and the same lines, but distinct parallel lines. I'll make x plus y equals 3 and x plus 2x plus, just say x plus y equals 5. How many equations are there? 1, 2. How many unknowns?
2 equations. Oh.
2 equations in 2 unknowns, no? Draw the graphs. Draw the graphs. We already drew the graph of the first one, x plus y equals 3. This is x plus y equals 3. Now draw x plus y equals 5. Let us say 5 is there. X plus y equals 5. No? What is in red? Ayyo, mamma. And then the pair is done. What is the red one? This is 5 here, 5 here. Second equation. This is x plus y equals 5. How many solutions? Points of intersection? Do they intersect?
No.
No. Parallel lines. Therefore, how many solutions are there? A solution geometrically is the point of intersection, point common to both. Both must be satisfied. No? Is there a common place where they meet? No solutions. Parallel lines never meet. Therefore, there are no solutions. No solutions. See, the O-level stuff, no, but this leads to something really interesting. For this linear system, I gave you 3 examples, 2 equations in 2 unknowns. First one, unique solution. For this example,
Sir,
yes.
the height lecture kaddiyena.
There are 3 possibilities. In fact, not only for 2 by 2, for any linear system, these are the only possibilities. Very good, you said that. Okay, so I'll see you on Friday, 8 to 9. Tell the others.